In this video, we are going to continue our discussion of section 11.6 by discussing the paraboloid. So let's first determine how to tell that it is a paraboloid. So the first thing that we need is three variables with two squares. So three variables with two squares. The second thing is that the variable with square are both positive. So variables with squares are both positive. Couple notes. It opens along the axis of variable with degree 1. So just like a parabola, this is going to open up in a direction. And it opens up with the variable in degree 1. In this example, this standard form, that's z. All right, so the c here gives direction. All right, and then this is weird because we're in 3 dimensions, so we can't really talk about up, down, left, right, stuff like that. So positive, if it's positive, it opens towards, this is going to feel silly, positive axis. Negative opens towards negative axis. Towards the positive numbers, towards the negative numbers. Right, and then the last thing, set the degree 1 variable equal to 0 to get a trace on a coordinate plane. Don't know why I wrote G. Coordinate plane. All right, so those are the directions on that. Let's take a look at an example. So we're going to graph this thing. So first let's talk about how to verify that it is a paraboloid. The first thing is there are two squares. All right, and with one negative, think about moving that z over if we had to. And it's kind of weird, and we'll talk about that a little bit. So it's opening towards positive. So this is a paraboloid opening along the z-axis towards positive numbers. All right, and you can tell because there are two squares, and maybe you're like, well, what is that? Well, if we just think about moving that over, so we get, I'm going to put the x squared plus 4y squared first, we get z plus 4. So if I think about this as maybe like that, right? Maybe some of you are seeing it already, but this is just the graph. If the 4 wasn't there, shifted down 4 on the z axis. All right, just like if we had something like this, f of x equals some function, we'll just say that, and we plug in x plus 4, it would move, well, that would move the function to the left, but if I put a plus 4 on the outside, that would move the function up. So if I'm thinking about comparing my new function, I would minus the 4 over. I may have confused you there. Just think about when I plug in things like if I have the x squared plus y squared, I think I can clear it up here. equals 9, and I plug in like x minus 3 squared plus y plus 2 squared equals 9. Well, the center of this, of the circle, is 3, negative 2. All right, the way we pull it out is you would take the opposite. The real reason it's working is that it would take 3 units to make this inside set at 0. It would take negative 2 units to make that set at 0. So here, it would take negative 4 units to set that at 0, meaning that we would get the actual graph if we moved our full graph down 4. This way that what's really happening is you're resetting your graph when you pull it down negative 4. I hope one of those made sense. I think the first one was nonsense thinking about it, but we're okay. I think I could clear it up there. So let's follow the directions on the last page. It said we're going to let z equal 0. So if I let z equal 0, I get x squared plus 4y squared equals 4. When you're plugging things in, what you want to do is plug things in that make sense. You don't always have to do the same numbers. Just think about when I plug something into my equation, is it going to give me something nice? If it doesn't give me something nice, I don't want to plug that in. So the reason we chose 0 here is because we get that nice 4, and 4 goes both into 1 and 4. That would just be staring right here and thinking about, okay, what would be nice to have on the right-hand side? Well, if I have a number there, I'm going to want to divide by it, so I have a 1. Well, I have a 1 here and a 4 here, so I better make sure that the right-hand side is a 4. That way when I divide, just like we're about to do here, this gets me x squared over 4 plus y squared over 1 equals 1. And that tells me right away it's an ellipse. We picked a nice, pretty z to give us an ellipse. So that's what you're going to be doing each time, is picking nice numbers to plug in for z, or the variable without the square. All right, so we know now when z is 0, we have this ellipse. So let's graph that. Remember, this is a squared, this is b squared. A is 2, so that's 2 in each direction. B is 1, so that's 1 in each direction. So I get this ellipse when b is 0. So let me get some dotted lines. All right, we have something like that. I also know that it is shifted down 4 units. So I have this, it's a paraboloid, so it's a parabola. It starts down at negative 4. So if it was shifted no units up, I would have 0, and then I would have picked another z that would have made a pretty ellipse somewhere else. Okay, so I get that. This would be able to see those. And then we have this going up like that. And they do go on, right? I should have done that. Oops. Now while I'm here, I'll do this one. They do go on forever, like a parabola would, in each direction. So mine always lean to the left. Even the one on the paper leans to the left like that. I think I curved that too much. So let's take a look at an actual graph. So there is that graph. My graph doesn't even go down all the way to the 6. I could go over here and change it. General graphics. So there's a way in here. I'm not finding it right now. Standard view. There's a way to manipulate it to get it to move. I'm sure one of you guys are like cringing right now because you know how to do it. So mess around with it, but you could see the general shape here. You can see how it's getting smaller as we go down. There's the parabola on one side, right? And I turn it another way, I'd get another parabola. So there we go. There's our paraboloid. Paraboloid.